Scaffolding is a brilliant invention. It's affordable and simple to assemble. It's been for many years the #1 choice when it comes to work outside of a building. But when it comes to speed and mobility, it's been outclassed by SKYJACKs and boom lifts, which all professionals now use on construction sites. But I'm no pro, and this summer I'm gonna build an house extension as an office, so I won't be editing in the living room anymore. And I cannot afford a SKYJACK or a boom lift. But I do have a little Massey Ferguson with a quick attach system that is capable of lifting heavy loads. And I guess I have too much time on my hands and surely not enough brain cells left to red flag me that it's probably a bad idea. But I'm gonna build myself my own portable scaffolding tractor attachment unit. But first, let's gather the material we need for this build by cutting into pieces the old flying machine. Here, I simply want to disassemble and cut what I can from this project, starting by the swivel base, which is separate easily, right? I don't think I put a bolt somewhere. Well, okay, well, at least let's unbolt the bottom bearing. Nope, still frozen solid. I think the problem comes from this seized shaft in this rusted bearing. Okay, enough of politely asking to split apart. Let's bring the big guns. What? Still stuck? It defies the laws of physics. Then I spotted it.
There's a bow!
I could call it good and throw in the bin these two pieces, but the shaft is made out of 4140. Plus it's a good reason to play with fire. Boys will be boys. Now more playing with fire. But don't worry, I know this is not a video on how I chop to pieces the flying machine. Even though to me it's very satisfying to watch. Only gonna take what is really worth it. But maybe I could use these legs for something else? Bye-bye, flying machine. And with that, I refilled my steel pile. But the tubings are in really bad shape. They might just be good enough for a field fence. Anyway, by going to my local trash container, some of you will recognize the reminiscence of some of my old projects. Oh, and I found these barrels and this old water heater that inspired me my next project. Guess what it is in the comments? As a hint, it involves water and fire. After much thought, I bit the bullet and bought new tubings. I know, Viny's on the loose, working with brand new steel and no crappy rusted chunk of metal. What is going on with me? But don't worry, the first 3 minutes of this video you just watched was not a complete waste of your time, cause I'm gonna reuse this from the flying machine. Yep, that's it. Okay, although I need a plan for this project, you won't be able to purchase this contraction of death on my website for obvious safety reasons. But what you can find on my website is the plans and the XF files of my magnificent welding fixture table and custom accessories, which I'm gonna use a bunch to build this scaffolding project. First problem of the project. Because my milling machine is at 45 degrees in a corner, I cannot put long pieces in the vise. I know, my new mistake. But what I can do is use my mag drill on my fixture table. In the last episode, I said that I didn't know what I would need these pusher clamps for. Man, these came out so useful. I already built 2 of them. Pretty sure I'm gonna make 2 more. I could have used my press drill, but some of these holes need to be somewhat precise, and with the big overhang I would have on the press drill, the combo mag drill and fixture table was a sure bet. And this is where we start to see the benefits of having a fixture jig. Have you seen how bent this flat bar is? Okay, the goal here is to build 2 telescopic platforms, one on top of the other. And yes, I could have used some C-channels to do the outside framing. But, and it's a big but, I'm really limited by the lifting capacity of my tractor's loader, which should be around 1,000 pounds. Probably less. So for its lightweight, this is why I choose the 2 angles and the flat bar. You'll see throughout the build that I made strategic choices to minimize weight of the scaffolding attachment. The downside of using this type of sandwich structure is the amount of welds I need to bother on. And I don't want to turn this thing into a giant banana. To counter that, I first tack weld one side, flip the part, then tack the other side. I flipped it once again and I started laying down some welds with shim blocks to prevent bending. And it's already a banana. Yeah, even with the shims. Nice. And now that's a pretty fucking nice banana. Seriously, it's bent about an ½ inch over 6 feet. Yeah, perfect. Keep in mind that the telescopic platforms are like big drawers. With a bend frame, I'm off to a bad start. I'm no professional welder, but I saw pros bringing back bends with a bit of heat. Well, I mean a lot of heat. So my plan is to heat up the 3 lips, which I think should make them expand, but it's gonna be fine since everything is clamped down. Then, using the last remaining of Canadian snow, quickly cool them off in hope that they will contract back to their initial form. Then I repeated this process at the 2 extremities, because it was hard to heat up such a long part. I mean, it's far from perfect, but compared with what we started from, it's way better. Then I did the other half of the frame. And now I was ready to put the 2 halves together. By the way, if you like my content and want to encourage me to continue creating such silly projects, you know the almighty trifecta of all YouTubers: subscribe, like, and comment. Seriously, you have no idea how important these are for our content to be pushed by the algorithm. Plus, me and my YouTuber buddies, we like to compare the size of our channels just like we would in a contest. Have you seen how big mine is? Oh, yours has grown a lot in the last month. So please help me get that behemoth of the channel. Thank you! Since I'm still learning the capacity of my skills with the fixture table, I double check the overall squareness of the frame. And we've got
7/8, 5/16. 7/8, 3/8? Yeah, 3/8. Let's call it 3/8. Hey!
So we have to keep in mind that we have an angle on top of another one, on top of a flat bar, laying by another angle on both sides.
And even though with all of that, I'm only 1/16 off. It's already a veto. Oh, I love this table. Hee.
Okay, it wouldn't be a Viny's project if at one point it was not using used parts. Because I found these wheels and holders. Not gonna use the aluminum yet, because it's the bearings that I'm after. With a little bit of tappy tap tap, I extracted all 12 bearings that I need for the telescopic platforms. Oh, and for sure, I'm gonna keep these wheels. They'll live, let's say here, for the next few years. Since the holders were already machined to fit the bearings, I'm gonna tweak them just a bit, again to reduce weight, cause every gram counts. Don't ask me why, but to locate or secure a bearing on a shaft, my first choice has never been to use a circlip. But on this project, I kick my designer's butt, grind myself an high-speed tool and nudge those holders in a split second. For now on, circlips will be my go-to for that type of application. Look at it. I know, it's all loosey-goosey, but it's good enough for what I need it for. After I welded these modified holders on the main frame, it was time to build the 2 telescopic platforms. And the process was quite the same as building the frame. We drill, we machine bearing holders, and we weld everything together. Except that apparently I welded these backwards. Once I built the two platforms, it was time to put them to the test in the main frame, and this is why I took some extra time to make everything straight and square. Ta-da! Oh yeah, I like it. Now I'm starting to work on the scaffolding base. Again, I'm using the fixture table, but the thing I wanted to point out to you is that even though I took extra care to cut all the tubings at their right dimension using a good industrial saw, once again the table was revealing the obvious truth. All the parts were just a smidge too long. Did I told you how much I love this table? Anyway, just for the fun of it, and because in the previous episode I tried the fireball test, which in resume was a test to see how precise and flat we could build a simple square out of tubings. So I wanted to see how flat I made that loop.
Barely.
22 thousandths of an inch. That's
22. That's 22.
oh yeah, 22 thousandths of an inch.
Nice.
With all the laser cutting I've been outsourcing lately for the fixture table, I kinda neglected a bit my plasma table, but I'm back on plasma cutting to produce all the parts needed to fit with my tractor's quick attach system. And my plasma machine let me know that it didn't appreciate the neglectness that it received lately by stopping frequently to cut. But after a few swears,
Oh goddess.
I was back in business. Once one of the two attachment points was completed, because yep, I'm gonna make two attachment points, and you'll see why later in this video, but once I made the first one, I went to check the fit with the SSQA. You see, an SSQA is a very clever device. It's made out of a series of angle pieces that create corners to cleverly wedge the attachment unit onto it, and you lock it in place with two pins, also tapered to keep that wedging principle, so in theory, there's no play. One bottom side is a bit too loose for my liking.
Moments later.
So after some minor adjustments, I did a second trial and the fit was quite good.
Nice.
Then I completed the base by linking together the two side loops. Am I the only one whose dad used to say when you were young that sitting on something cold was bad for hemorrhoids? Am I the only one? Side story though, I had to Google the word hemorrhoid to get the English pronunciation right. Don't do that, cause man, the pictures you're gonna get. Ugh. You see, I made two attachment points on the base, one perpendicular to the other, so I'll be able to have the tractor either facing the scaffold or have it from the side. So depending on the access I'll have to the building, I'll be able to choose the best attachment point depending on that situation. The base was done, and it was time to put the four long legs that will support the main platform. By the way, the platform will sit at 7 feet from the ground, but I still have work to do on it, so working on a ladder won't be ideal. Instead, I cut the legs in two, and it will be easier to complete both sections since they'll be at an arm's reach. Then I attach the railing that will also serve as an attachment point for the two telescopic sections, just like a suspended bridge. You see, the initial plan was to use a manual winch to connect the far end of a telescopic platform using two pulleys. But after playing a bit with the platforms, and because I knew that the pulleys will let the cable slide as the platform will twist and bend under my own weight, I knew this idea was crap. And yeah, I know my portable scaffolding might not be OSHA approved, but the winch I was planning to use is, quote, not for lifting humans. But does it count if it's just to keep them suspended 13 feet in the air? I mean, theoretically, I'm not lifting anybody, right? So I've got a small idea on how to suspend the telescopic platforms, and I'll start by reusing cables from the flying machine, and also being added bump into my camera. Now I'll fix the cables on each side, and I'll make a pushing and locking mechanism to create tension on the cables, and I'll do that using this, some extra length from the Smart Booza chain. Nothing like the smell of burnt O-rings and oil. I'll add a hook at one end and it will push against it, locking in place the two telescopic platforms, at least in theory. I wanted to try it out right away, so I'm using my tractor's loader as a counterweight. It's making contact, but just barely. Perfect. Okay, after resetting my counterweight, it was time for the first test. I know at first glance it looks right now a bit wibble-wobble, but it was because I was lifting the opposite end of the platform. Otherwise it was looking pretty promising. And now I'm apparently the Karate Kid? So the locking mechanism worked great, except... Ben voyons encore, after I fixed that little mistake and finished the other side, I've built a bridge. There's nothing like a good old rocking test to make sure I'm not gonna die on this. Now for the floor. And wood was not my number one choice, but the tired Karate Kid chose the easy route for that part. One thing for sure, splitting in half the scaffolding speed up the fab process. Sure, it's gonna come back and bite me on the ass when it's gonna be time to merge the two parts together, but still, it was the right move to do. Oh, Viny, don't forget to pick up those tiny little cutted screw bits. As you'll see, they love to snuggle up in your tires. I've got a good recipe for anti-slip coating. First, we need sand. Nice! Just a smidge more because we never have enough of this stuff. Perfect! Then we mix the sand with some paint. I already got the can about halfway full. So in half a pint, you put 1 tablespoon of sand. Stir thoroughly. That should do the trick, but just to be sure, let's add another one. And with that, we should be good. So here goes number 3. You know what is not slippery? More sand. Okay, more sand will cause issues when applying the paint, so here goes another one. Stir again. Add 1 last tablespoon, and at the end you should end up with the consistency of a pancake mix. Well, I don't know how, but the anti-slip mixture I just made, it was too liquid. I should have put more sand in it. But anyway, after this failure, I used a strainer to apply the sand on the paint. Once dry, it's literally like a giant sandpaper. In the accessories package that you can get on my website, I included this super square, and by adding an L-shaped plate, it becomes a pretty clever tool to install the legs. On this square, I kept the bottom edge sharp, so it's easier to align with the mark. Okay, big spoiler here, but I'm not gonna rely on my loader's hydraulic to keep the platform in the air. Cause I know this thing is leaking like crazy, but I'm gonna have adjustable legs and these will slide in and out from these tubings. To reduce weight, I decided to add racing holes to these leg supports. And this is how I clean the inside of the tubing from the dross formed by the plasma cutting. Cause I really want to get a good sliding motion. So without the holes, one support weighed in at 13 pounds. And with the racing features, I cut it by half the support's weight. After fixing the leg supports to the base, it was time to build the legs themselves. And unfortunately, my table is not wide enough, but I can attach towers to one side, thus increasing the workable width of the table. I decided to tilt the base and insert the legs before installing the platform, because once the platform is installed, the entire scaffolding will be very top heavy and probably harder to tilt over to insert the legs. So I guess that was the right move to do. The downside of already having installed the legs is that now the height to install the platform is even greater than before. But that's okay, I've got a trick up my sleeve to get around that problem. Kids, don't try this at home. I'm what you can call an idiot with limited equipment. Even without my sensei, Mr. Miyagi, I can feel when I go over my comfortable sketchiness level, and on a scale of 1 to 10, that might be a level 12, way above my pay grade. And I know that attempting to install and probably drop the platform from 13 feet high could have been great content, but I convinced myself that removing the legs was the smart thing to do. I guess Mr. Miyagi would have been proud of me. And without the legs, it was a piece of cake to install the platform, but I kept the inverted fork setup because I don't have much reach with this loader. Designer tip number 4. Add cross braces when it's possible. Here I added 3/8 rods in a X pattern, and it made a hell of a difference. Right, I needed once again to tilt over the scaffolding, but this time with the platform on it. As anticipated, it wasn't that easy to do. Then I put back the legs, backwards.
Ah, no! Football ball! Ah!
And putting the platform back on its feet was even harder than tilting it over, because my forks kept getting stuck with the bits of the legs sticking out. I did the first trial at the lowest setting to give me a chance of surviving in case of a failure, but I blurred that image since it's a highly R&D classified footage. After some minor modifications, it was time for the first full height trial. This thing is awesome. It's 16 feet wide and the floor is at 13 feet from the ground, meaning that with my height, I can cover a wall of at least 20 by 20 before moving the platform. I worked quite a few times on a scaffolding, and this portable one is far more stable. Well, it's not even comparable, because this thing is not shaking a bit. And the trick is that I barely lift the front wheels of the tractor and use some of its weight to gain stability on the platform. It took around 7 to 10 minutes to set up and about the same to dismantle. As I mentioned previously, I've got some home improvement to do this summer, and this platform will be super handy for the build, but also right now to do some maintenance around the house. Plus, I already use it to uncover my travel trailer. Took at least half the time and was twice as enjoyable to do, because I was not constantly climbing up and down on a ladder. Alright, so apparently I still have some minor issues to fix, but I'm Viny and Mr. Miyagi and I will see you on the next one. Oh, and don't forget the ultimate trifecta: sub, like, and comment. Bye bye!